normal session. So I hope we're ready to start. I'll be admitting more people on the go if someone else joining, but it's 4:30 here, so let's begin. Okay, Victor, hand this over to you. I'll mute myself.
Yeah, okay, thanks. So yeah, basically today I'm going to go through the workflow of reverse engineering of this model. Pretty simple part from one side, from other side. It's a lot complicated, but it's manageable to do that in like 2 hours or something, probably less. And as we are typically spending around 1 hour or trying to do that in less time, so I will just show some basic actions, how can this be done, and then we'll jump straight to another section. So I won't be showing exactly every single part how this was done, because all these actions are just repeating actions. So probably, I think I will just start over with like absolutely new file. So of course, it's misaligned as always. All our scan data is. So starting just with extracting primitives. Let's say this is going to be our cylinder. Out the constraint. Tolerance looks fine. This is going to be first feature. Then I will use this as a plane, constraining it to our first cylinder. I will create another plane here to define our last axis. Okay, should be good enough. So, solid scan data, align by coordinate system. And then this is a front plane, cylinder, and another plane. It's going to be right plane. Okay. So since our scan data is aligned, we can proceed with extracting more primitives that we will use for cutting our mesh apart. Here will be another plane. We can make it parallel to plane 2. Which one is this? Here. And then another plane here. And this will be parallel to plane 1. Same on this side, of course, same here, and same there. But we have several places where it's more difficult, where we need more than just a plane to cut this mesh apart. For example, this place. So we cannot just use plane here. We need like extruded surface and the plane. So in order to do that, I'm creating plane from the surface. I will just create another sketch, mesh sketch. Yeah, I will keep it on slicing plane. So extracting circle. Select it up, so probably will change some sizes. And so yeah, this one is locked now, so we can create tangent lines. And just trim circle. Extrude surface in both directions. Be completely sure. So now we can trim these two. Single surface right now. Okay, so this is good. And another part, which is even more interesting, requires a bit more actions, is this face. So basically, it's almost flat. Also, we need some vertical surface here from this flat position, but it's kind of curved, so we have to invest a bit more time to recreate this. Basically, again, setting plane, making it parallel to very first plane. Okay, and yeah, going with mesh sketch just to define circle again here. And this time I have create it as a solid. And the reason for that is because we can use our circular surfaces as reference points for our revolving mesh sketch. This. From here, we need basically I'm going to copy this entity. Expand its axis. Okay, create another line. And like this too. Let's calculate the automatic radius for it. Let's say it's 3.3. I'll just extend it and see how it works. Yeah, good. Okay, so this is the first step. And considering we still have here this door, let's create this as a one single cutter. I'll just add this plane, we don't need it anymore. So the track primitives again. The surface is a bit wobbly, not that great quality, but let's put cylinder there and make it parallel to cylinder one. Yeah, it looks good enough. Great. And now extend this one to both directions. So now we can trim these two parts. Have this kind of surface, probably now. Okay, so this is going to be our cutter. What else before cutting? Yeah, just another thing is we have to get rid of some geometries that we don't need. As example, this countersunk, I don't know. Most likely it was used to machine this spindle. Basically, going to scan and go from back. Almost worked out. Yeah, perfect. So yeah, this way you can get rid of unwanted geometries. So now we can start cutting our mesh apart. Basically, again, we're going to edit scan, clicking on these buttons, split mesh with other solids, surfaces, or meshes. Selecting one of faces, one of surfaces, whatever what you want to use for cutting your mesh. I'm going to use envelope and click preview. Here we see preview how this mesh is going to be divided. And here we have some error because the planar surface is a bit too big and it's reaching another sections of our scan data, what we don't want to do. So cancel, close this, let's just resize it. Stay on this side as well. Repeat all this. Let's preview. Okay, looks good. Preview. Okay, good. So now we have 3 individual meshes. We can come over, select our main body. Well, this is the only one mesh that we want to keep. It's good. Now this is about this. Surfaces. Done. Okay, let's cut this part now. Again, let's scan. Trim with surface. Select it, keeping the same envelope. Okay, here we see that we don't have enough offset on this side. So we can just adjust amount of our envelope distance. Let's say 0.5. Okay, now it looks great. Except that, again, repeating, selecting one individual mesh. Perfect, we got this one. Probably now we can do absolutely the same actions here. Yeah, looks absolutely good. So basically, this way you can cut apart all your mesh. And resulting, I'm going to jump to another section right now. Okay, this one, this one. So at the end, you will end up with such completely cheese-looking mesh. And initially here, we can start applying our automatic freeform to this, to what left over from our complete mesh. selected on the freeform. Basically, I guess I'm going to leave everything as it is. Just don't mark improve all boundaries. Preview. Okay. Here we have result of our automatic freeform.
Sorry, can I just ask a question?
Yes, of course.
With you trimming away certain features before doing the auto freeform, does that make the auto freeform work better?
Victor, let me explain. Absolutely, this is the right way of doing this.
Right.
Because, you know, automatic surfacing is really powerful tool. But if you try to use it in general on general objects, you may often fail and not get what you want to.
Yeah, because it's the
For example, on this part, if you try to do automatic surfacing, it does not recognize the cylinders. This is just the surface, and it wraps around, and you don't get any information.
Right.
What we show in this example is typical hybrid modeling, where you are really interested to have control over the primitives with in a parametric way, for example, changing the radius later, or make sure perpendicularity, the radius of the cylinders, of the holes. And just from practical point of view, this is what you need if you use this part after you manufacture it. But the rest, what we see on the screen, it really doesn't matter if it's plus minus 0.1 or even 2 millimeters. This is probably casting. What we try always to speak with the customer is what you actually want. Why do you want to do reverse engineering? What is your next step? Yeah. And this is a typical example from the reality, according of my understanding, of course. If you have any other thoughts, share with us. But yeah, this is
that makes perfect sense. Yeah, I've never seen it. I wish I'd done something like that a little while ago.
Well, none of the current tools on the market offer this, especially the traditional CAD packages. If you take this object and use the curves and fill surfaces and tangency and stuff, you lose days. While here, Victor's showing this in real life. If you want to make this properly, according to him, it takes you maximum 2 hours. But that's why what we do now is split the job into two, separate the two problems. One is the prismatic areas. The other one is, which we don't care about too much, about the accuracy.
Okay. No, that's great. Thank you.
Yeah. Okay. Well, actually, there is one more thing related to this question what I could take a look at. So basically, if we are using auto freeform just on this scan without cutting it apart, we will face a couple issues. Let's see if we can take a look at this in reality. It looks pretty good, except of one thing. For example, yeah, of course, you see that our planar surfaces aren't planar right now, and so on and so on. But for example, what typically we will do later with this approach, we're going to extend the boundaries outside, so we can later trim them with the same planes that we used to cut our mesh apart. And if we will try to use these planes right here, for example, in many cases, you might face issues with some bumps and in irregular surfaces, so you won't be able to trim it properly. Yeah, exactly, as you can see here. So actually, you can trim away this, for example, and this, but still, you won't get like planar surface here. So that's the main reason why we are dividing part first by eliminating these, as Costa said, prismatic surfaces. So we have full control over them later. So yeah, we have this, and initially to make everything work perfect, now we have to extend these boundaries. Basically, we're going to edit our freeform just by selecting boundary. Come on, world. Oh, that's good enough. So by holding Alt key, just pulling it away, by creating another line of polygons. Same on this side. Same goes here. Yeah. Probably. No, come on. Green. This one. And on opposite side. Okay, we're going to do the same on these surfaces here, and same as here. I want to take a look at these two. These are a bit more complicated. So initially, what we can do here, break here. So we just try to connect them. Okay. It looks already better. So basically, how we can figure out things here. Here I'm going to use extrapolate tool. It takes our boundary from one cut to another cut and just extends it. And polygon flow direction, let's call it like that. And here, you go like more or less vertical up. And this surface was coming like horizontally. And now we will have to manage to connect all this together. Apparently, it doesn't look too pretty, but let's call it easy game, let's say so. We have a problem here. Okay, I'm going to do it in a different way. Let's set it to this corner. Okay, this also. I'll call the gap. So you can just grab it. Yeah. Yeah, basically what I like in this freeform approach, it's a bit different than like automatic surfacing you can see in other softwares, because this is like built as a sub-D model, so you can easily adapt it as you want, easily change everything just by pulling your vertices or adding some smoothing. This way you can get it really nice and smooth, exactly where you need that and when you need that. Like that. So now I can get back to this trimming surface that we're going to use again. Now these two surfaces are completely intersecting, so perfect. And actually we can start right away with this one. Let's see how it goes. This way we're obtaining a single surface again.
Yes, this is the way you. It's really important to understand what we do here, is because if we didn't make it with this approach, there is no way to make transitioning between freeform surfacing and the prismatic shape. So it's always good to extrapolate and try to make this bigger in a nice way so the trimming can work. For the trimming, probably you tried, the main idea is the surfaces really nicely overlap. So like Victor showed, make sure that this surface goes completely over the others. In the CAD industry, you know, these B-splines, etc., they may cause a lot of problems. And if you, in your project, if you find that this trimming doesn't work, just make sure that you have enough excess of the surface so the trimming can work. In terms of accuracy here, again, probably for the freeform shapes, you don't really care too much about the how close it is to the underlying shape. So this should be good enough. As you can see here, it's really important that these vertices go outside of this prismatic shape, so the trim can work in the right way. So.
You know, if we're talking like deviation wise, it still looks good. Okay, we can first we can come over here and bring it to snap mode and just snap these vertices back.
Yeah.
If it's that crucial for us, these places, so it's not a big deal. But like typically, as Costa said previously, for casting parts, it's not that important because that part is already formed by sand and it's it has deviation from the initially designed part. So we are just, in most cases, we are ignoring such small deviations in such small areas. But of course, it depends of you and your customer and what result you have to achieve from that. So you can manage all that pretty easily. Continuing our trimmings. Actually, I did it a bit too early. Let's hit cancel. Considering this, our surface is coming over to this side. We still have to edit this boundary here. And basically, I would suggest you to extend all these boundaries first and only then do trimming. So I have my overlap. Let's add some smoothness here. Keep close. Yeah, basically, what I told about extrapolating all these boundaries first, because every time when I'm entering back in this edit mode, after going out, it has to recalculate all previous trims, so that takes more time. Basically, when you have prepared all these boundaries before that, you just can go and trim one by one, and it doesn't have to recalculate like 10 times all these trims. You will save quite a lot of time and, well, probably some sweat of your laptop. This side, this side, this. Okay, again, we have finally single surface, so everything is fine. So, and probably we can take a quick way. Let's shift the plane to plane 3. Let's do another trimming operation, and then I will jump the next portion of our workshop. And sometimes when it's pretty complex trimming, you can notice that this sign is a bit laggy as it was right now. So I did trimming, it was still showing like multiple surfaces. And after like 2 or 3 seconds, it changed to single surface. So it understood that everything is fine. Just sometimes it takes more time than typically it is.
Yes, when it is a complex trimming internally, it needs to join the surfaces, and that's why it takes a while until we get this notification.
So absolutely the same way you can proceed and trim this side here, and basically all that is absolutely repeating. I'm just going to jump to next section, and we'll model one last bit that we need for our trimming. As you can see, I have trimmed all the surfaces. Everything is cold now, except of this spindle part. So for this, I'm going to use the very first cylinder that we extracted from our scan data. I'm going to use it for our revolving mesh sketch. But I'm going to use this more complete scan data because I have some groove here. Choose this position to create artificial defect. Basically now, again, holding shift, drawing around the points, fitting our lines by holding control and dragging around line endpoints. We're connecting them. Of course, this time I'm not going to model completely all this thread. I'm just going to skip it right now. This thing here. Here we can automatically calculate our radius, 3.2 millimeters. Here as well, 3.2. And this a bit beyond boundary. It's pretty good. So basically, at this point, we can do our revolve. Yes, and currently, we can see that I have a problem here. It's not intersecting enough, so we cannot trim it, and we cannot make it as a one solid body. So basically, easy solution, of course, you can go back to your sketch and simply extend this line so you have completely intersecting surfaces. After trimming, and we see that we have solid body. Click OK. Perfect. We have this built, and the last thing, last one step that we need to do is just to cut our bores and combs and things like that. So basically, our previously created entities we can use for cutting away from our solid. So here's the cut from selected solid feature, selected. And select the feature you want to use with the cutter. Okay. In this way, you can complete your model. The model has to here with this one. Okay, this version I haven't saved our cylinders, so I guess I still have some time. I'm just going to extract them quickly. Sides. Cylinder. To plane 2, create a stay. Select another segments of our scan data. Again, cylinder, again perpendicular to the same plane, create and stay. Then goes here. And why I'm usually keeping analysis on, so I can actually see. Here is actually this is a cone, not a cylinder, but by naked eye you can't really see because it's like really narrow angle cone. In most cases you can see that just a cylinder without analyzing tools. Basically, at this point it looks absolutely fine, but our analyzing tools, it's much more easier to understand that and take the correct steps to avoid errors in your reverse engineering projects. To be honest, I don't remember which plane was this, and none of this. Okay, this time I will leave it unconstrained. Those, basically all the rest we have. And this one, now just select on these cylinders and extend them so they go through the mesh completely, and basically completely through our body. Because we have complete intersection to be able to do trimming. Okay, so all of them are extended. We can cut them away with one single command. Just have to select them one by one. That was the last one.
I have a question.
Yes, of course.
What's the better way, to cut from selected solid or use the trim command?
Basically, it doesn't matter. It depends more on your, like, how do you see your workflow. But in this case, for example, if I have like completely these features, I can trim this feature. I can cut that feature away from solid body with one click. And actually, okay, let's do it a different way.
Can I say here? This is very good question about the cut from solid body or trim. Now, in general, all the cut kernels, they much more they like Boolean operation. This means that whenever it's possible, I recommend that you use Boolean cut or Boolean join. You can always use trim. Yes, that's true. But sometimes with the trimming, you may have really complex shapes and you cannot see which surfaces to be removed until you receive your final solid. While Boolean cut, you just pick the big body and then you say cut from me, and then it works. Well, in this case, you know, you may end up with hundreds of faces that you need to click and remove and stuff. So that's why, to answer your question, whenever it's possible, and if you use with solid shapes, try to use a Boolean cut, not the trim. Because here, yes, now I'm sure you can start removing, but you need constantly to keep an eye of the result, if it's okay and stuff. So,
Oh, okay, I see.
Well, in this case, it's not that critical, but sometimes you will face some problems where you have like a lot of surfaces and a lot of cuts on every surface. So that is going to be a mess. Plus, in this case, as minimum, I'm saving like 3 clicks on every feature. So it's like just a bit faster.
yes.
And yeah, you
Okay.
don't have to rotate your model all the time around to see if there is something left somewhere. Then start to like make it transparent to see if you haven't left any overlapping surfaces somewhere. So just Boolean cut is way easier in such cases. But you can go both ways. So it's same solid as I had with Boolean operation.
Okay, thank you.
Okay, so maybe now we need to ask for more questions. Anyone to join and give us more information. I really like to say a big thanks to Victor for this project. He did this. I know we are not very good to make classes, you know, so he was more focused to complete the job, just not to mess up and make sure that the actual model is completed. But I appreciate really his efforts. It's not this with the tools of QUICKSURFACE, as you can see, this type of projects easily can be implemented. Still, there is no magic. You need to make your decisions, make some planning, and decide and how you need to do this. But the general workflow is what we saw today. Is first, the most important first step is always align the object. Don't try to do reverse engineering on unaligned objects. Yes, I see raising hands. Go ahead.
Hi, I'm really enjoying this series you guys are putting on, but I'm still lost.
Yeah. Okay.
So I think I started. I had bought the Metro X and then bought QUICKSURFACE Lite. maybe just a suggestion on some of your videos. If you're doing any of the features or anybody's doing any of the training, let the person know on the video that it's for light versus pro. I had purchased the software thinking it could do some of the stuff, but I need the pro version to get some of those things like thicken, and a couple of the other things I can't use because I'm on a light thing, on the light version.
Good point. The thing is, QUICKSURFACE Pro is a complete package that can take you to the end, as you can see. The light version was for some people that they have their own CAD package already. You know, they're familiar, they're in favor with their own package. I don't want to say any names, but there are other CAD packages on the market. And people came to us and say, okay, but I don't care about your QUICKSURFACE tools. I want just to get my critical shapes and I'll finish everything in my CAD package, because you do booleans, you do this, but I don't need this because I have it. So what I'm missing is the ability to align the object, the ability to extract essential features, and then I can complete my job into the other software. And that's why we introduced the light version. If you can see, the price is nearly 10 times cheaper. and yes, you cannot expect to have this as in the pro functions. And that's why we would like to have something in pro that it's worth the price and the cost, because we invest resources here to develop this functionality. And what you see here, if you add it to the light version, then what's the point of having a pro version? So it's a bit complicated. People want lower cost of the software, but we also pay our salaries. We need to live. And if you just look a couple of years ago, a package like this one, which is still costs $20,000 and more. Now, if you buy a scanner with for this price, then probably it justifies the investment. But now we still believe that our price of €4,000 is still, how can I say, good fit for the users. So I don't know. I know it doesn't answer your questions, but
no, you're Costa, you're making perfect sense. I'm just, because I'm here in Canada, so 4,000 something euros is about 7,000 Canadian. I don't do enough work to justify it, but I'm coming around.
Yes, I mean, Victor's is here. You can see it. If you drop us an email, we can set up a private meeting with you. Victor's can go more in details on the light version, to what extent you can benefit with the light version, what you can do, and how far you can go. That
would be awesome. Because I'm missing something. I've gone through your videos, I've gone through the training stuff. I think I picked a really hard project to start off with. I volunteer at the Military Museum here in Winnipeg, and they've got an old engine, 1940s engines they can't get parts for, so I'm 3D printing them. It's display only. They don't fly these engines anymore. But I've got it scanned. I've got it into the QUICKSURFACE program. But when I export it and stuff, it has no thickness to it. And that's where I'm getting lost. I don't know how to make it so it's got some, so the 3D printer could, slicer program could see it.
Well, if you're using the freeform tools, you need to make sure it's closed. But send us an email. We'll see Victor's availability. We can set up a meeting and you can discuss with him, and we'll do our best to support you.
Oh, that's awesome. Awesome. Thank you very much.
Costa, I just joined a little late, but have you considered maybe like an annual pro, maybe something like 1,200, 1,500 euro annually? I don't know. Maybe that's easier for people. if you're doing this professionally, I think €4,000 is an easy expense, right? And that's, you know, I think bridging the gap between some of the features that maybe professionals, like a hobbyist or entry level people, want to be able to do small things versus the you know, the professional. It's hard. Pricing is hard.
I know. I understand.
It's really hard. So I get it.
I'm honest with you. We have a big push for many people like you, just asking for annual subscription on the pro version. So it's on the list for us to discuss in our team, and we're carefully keeping an eye. So thanks for this request. Yeah.
Well, I mean, I can tell you, I was, you know, coming from GeoMagick Essentials and then looking at QUICKSURFACE, like it was a no question, like pay the €4,000, done, right? Like that was easy.
Yep.
Yeah, I think it just saves so much time. It's worth it. So.
Well, yes. If you see the GeoMagick product line, you know, the light version is as much as the Essentials, which is the ex-real GeoMagick, which was at the price of $7,000. So we just offer it for $400 per year. Now, DesignX, you know the price. This is 4K. And now I see, yes, you are pushing us to offer a year subscription. Again, it's on our list. I don't say yes or no, but
oh, I was just throwing it out there. I'm sure you considered it. I was just seeing if that was something on your list to consider, but it sounds like you're there. Yeah.
Yeah. Something else that you want to see next time, or because we have these plans to run these workshops nearly every 2 weeks, depends on the interest and depends on the parts we have, but we would like constantly to do this. Yes.
Yeah. Can you open up, say, a week before, that we could send you a project that you could do with us on the screen type thing? So you get 30 or 40 people in, they would like to see how to do a pipe or like what you're doing here with these parts and stuff, something a little more basic, a little bit more complicated, and we could vote on it to say, hey, we would really like, and it's close to our flow, that we would like to see how you do it.
Oh, yes. Yes, definitely. We would like to do this. That's, if you send us after today your part, we can consider this and make the next workshop with your part. What normally happens is people do not like to share this with the public. They say, okay, teach me, but I just want to keep it for myself. I don't want to show my part. So absolutely, you're very welcome to send us an example project. We'll go through this internally first, and then we can set this up for everyone, so more people can benefit with this.
Oh,
so,
perfect.
Yes.
If people, sorry, go ahead.
Sorry, but in this case, just the thing, what would be nice if project that you want to use in this online workshop, if you could share this scan data with other people who are watching this workshop later and want to try their hand on the same part, so they can follow up this workflow and learn something from them.
Yeah.
Okay.
So that's a good idea. Of course, it's not necessary. There are sometimes parts that you don't want to share publicly, but you are ready to showcase them. So in this case, okay, but it would be really nice if you could share this kind of data with other people so they can learn something from all of this, not just watch and, oh, this looked cool. So you mean?
Yes, yes. We'll share, speaking of this, after this workshop, we'll share also this file. It belongs to Victor. He scanned this, and we can freely distribute. But again, sometimes some customers allow us to show the files, but they don't allow to share the actual data. And then we get requests from people like you. Yes, I would like to practice myself. And then we say we cannot share the file, so it becomes a bit of a mess. So yes,
Oh, so I've got a 1940. Well, I don't. The museum's got a 1943 Bolingbrook engine with what, 8 pistons or 10 pistons, and there's a lot of scanning that I could do, and there's no proprietary to it, and I think it would be good learning. So over the next couple of weeks, I'm learning how to use the scanner, and then I could do the raw data, send it off to you, and you guys could all decide what you want to do or something. Because
yeah, we'd love to do this. I mean, showing the user data which comes from reality is much more valuable for everyone, because we can share the actual use. What I always also try to speak with the end users is, when they scan something, I ask them why, what do you need to do? Do you want to print it after that, or you just put it in manufacturer, or you just making it for fun? You know, just before you begin, just ask these questions yourself. Why do you actually do all this stuff? So yes, please send us this, and we'll set up the next workshop with your data.
excellent. Thank you very much.
Thank you.
We always try to keep it within an hour, and 1 hour is already gone. I see Grant is wishing more about flattening or unrolling workshop. We made the last one was actually with the unrolling. Grant, I will send you the link for the video so you can see. Yep. Make it 2 hours in the future. We can stay for 2 hours. It's simply people get bored, and I'm not pushing, I'm not running to stop it now. It's just more if you have more questions. Okay, you're asking about mesh splitting with curves. Yep, I'll make a note, so next time we'll show this. Right. What about the light, quick surface light perpetual license? I don't know who you speak with, but we do have this option available for purchase. I cannot share with you right now prices. If you for the quick surface light perpetual, it is available, so you can purchase. If you are happy with the quick surface light and you don't want to pay every year, you can buy light perpetual. What we offer, if you have already purchased your first year of quick surface light and you want to buy perpetual, we will simply deduct this first year, so you only pay for the perpetual license. Just send us an email, and I will reply to you in details how you can purchase quick surface light perpetual license. All right. Are these freeform surface manipulation tools available? There is a Ian. Freeform surface manipulations, are they available for SolidWorks? Yes, you can do the things in SolidWorks as well, manipulating the freeform exactly as you can see in current quick surface, but then the actual splitting and trimming you need to do with the SolidWorks tools, because they are the CAD software that is used. Okay. I think it's time to close the session now. I'll just stop the recording, and I'll share the recording